Hello friends, this video on hydrogen part 9 is brought to you by examfear.com. No more fear from exam. The next is the covalent hydrides. So in covalent hydrides, we have elements which are more electronegative than hydrogen. Please note they are more electronegative than hydrogen and they are generally p-block elements. For example, chlorine, water, carbon, nitrogen, and with this they form a covalent bond. Please note they form a covalent bond. For example, if we talk about HCl's, chlorine has 2, 3, 4, 5, 6, 7 and hydrogen has 1. So chlorine want to take 1, hydrogen also want to take 1. They will do a covalent bond here. So hydrogen will share this atom with chlorine and chlorine will share this atom with hydrogen. So they have a covalent bond and that's why they are called covalent or molecular hydrides. Correct. And there are three categories. One is the electron deficient hydrides, which has less electron. The other is the electron precise, and the other is the electron rich hydrides. So let's discuss this. So we talk about electron deficient hydrides. So these hydrides, they have less electrons. For example, if you draw the structure of BH3, so let's draw BH3. B has 3 electrons, hydrogen has 1 electron. Correct. So now if you want to create a structure of this needs 8 electrons to get formed, right? So it will take H, it will form with 3 hydrogen. So this hydrogen needs 2 electrons, it will form a pair. This needs 2 electrons, form a pair. This needs 2 electrons, form a pair. So now if we count the number of electrons which are there with B, right? Boron, it has 2 plus 2 plus 6. So boron has 6 electrons. How many electrons it needs to become stable? 8. So it is not stable, right? So what it does is, in this case, generally they don't exist in BH3, but they exist in B2H6 form. So if you see here, this is boron, this is boron, this is hydrogen, 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 hydrogen. So if you see the way it exists is, I have this boron, I have this boron. So this has 6 hydrogens here. So this pairing is done, we have seen here, BH3, BH3, right? So it has 6 hydrogens. So what we'll do is, this guy will also pair with this hydrogen, and this guy will also pair with this hydrogen. So now this guy has 8 electrons here, right? 2 from this, 2 from this, 2 from this, 2 from this, 8 electrons. This guy also has 8 electrons, 2 from this, 2 from this, 2 from this, 2 from this. Total it has 8 electrons each. So thus, in this case, BH3 doesn't exist actually, it exists in B2H6 form. Similarly, AlH3 also doesn't exist, it exists in Al2H6 form. Right? So they are electron deficient hydrides. If you talk about BH3, they have less number of electrons than required to attain the stability. Correct. The next is electron precise. For example, CH4, if you form the structure of carbon, there has 4 electrons here. Hydrogen has 1 each. So each of the hydrogen will form a covalent bond. So now if you see, the carbon has how many electrons? 1, 2, 3, 4, 5, 6, 7, 8, right? 4 itself and 4 from hydrogen. So 8. So exactly 8 electrons. So they are happy. They have exact number of electrons they look for. Then they have something called electron rich. They have more number of electrons than they require. For example, ammonia, if you see NH3, ammonia is 1, 2, 3, 4, 5. So now if you see ammonia, you have hydrogen, 3 hydrogens here. This will form a bond, this will form a bond, this will bond. So if you see, this is extra, right? These 2 electrons are extra, we get star. So that's why if you see ammonia, in case of ammonia, you have 2 extra electrons, right? And one, it has lone pair. Same thing with H2S if you find sulfur, 1, 2, 3, 4, 5, 6, and you add hydrogen here. 1 hydrogen here, 1 hydrogen here. So if you see, there is 1 lone pair here and there is 1 lone pair here. So we have 2 lone pair here. Same thing with water. 1, 2, 3, 4, 5, 6. Water, you add hydrogen, forms a bond, forms a bond. There are 2 extra lone pair here. They have electron rich hydrides, they have extra electrons. So hope you understand. Electron rich have extra electrons, for example, water, sulfur, ammonia. Electron precise is exact number of electrons required. They don't have extra unpaired electrons. Example, methane, SiH4s. And then electron deficient is something which has less number of electrons. than required. So it exists in, it doesn't exist in BH3 form, it exists in BH3 to the power n form, where n can be numbers, so you can form a big structure so that it becomes stable. Correct. So let's take some examples here. What characteristics do you expect from electron deficient hydride with respect to its structure and chemical reaction? So we have explained electron deficient was BH3, we have taken, right? So B has all this hydrogen consumed, it still has 6 electrons. So since they don't have 6 electrons, so they will exist in what? Polymer form. Right? For example, if you see B2H6, so it is BH3 to the power 2, not power twice. Example, same thing, ALH3, it also exists in N form. Correct. Second thing is about chemical reaction. So since they are electron hungry, right? They are electron hungry because they have less electron, so they accept electron. If they accept electron, they are what? Lewis acid, right? Because Lewis acid is something which is electron hungry, they accept electron, so they are Lewis acid. Now let's understand the covalent or the molecular hydrides characteristics. So they are soft and they have low melting in boiling point. Why? Because they have weak interparticle force, covalent bond. The next is they are poor conductor of electricity. Yes, because they don't have iron. If you talk about NaH, sodium hydride, they have ions. But if you talk about NH3, they don't have any ions. They're all covalent bond, right? So they don't have any ions to conduct electricity. So they are poor conductor of electricity. If you talk about solubility, so they are more soluble in organic covalent. Why? Because they are covalent bond. So since they are covalent bond, in ionic bond, they are more soluble in water. But in covalent bond, compounds, they are more soluble in organic solvent. They undergo thermal decomposition. If you heat it, it breaks. They are strong reducing agent. Also, some of them liberate hydrogen when they react with water. So when you react with water, they give hydrogen gas. And if you see in a given row, the covalent hydride become more acidic when you move from left to right. So if you see, these hydrides are more acidic. This is less acidic. So if you see, CH4 is less acidic, ammonia is more acidic. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.